Given the mean and the standard deviation, we're being asked in question 1 to label the points that are within 1, 2, and 3 standard deviation from the mean if we have a bell-shaped curve. For the points that are 1 standard deviation from the mean, we're going to add and subtract the standard deviation, 1 standard deviation from the mean, which is 0.261. 0.261 plus 0.034 will be 0.295. This point is located to the right of the mean. Now, 0.261 minus 0.034, 7, 2, 2, and 0. 0.0227 is located to the left of the mean. 2 standard deviations from the mean, 0.261, which is the mean, plus or minus 2 times 0.034. 0.261 plus 0.068 will be equal to 0.329. 0.261 minus 0.068 will be equal to 0.193. 0.329 to the right of the mean, 0.193 to the left of the mean. We asked to label points that are 3 standard deviation from the mean. The 2 locations are 0.261 plus or minus 3 times 0.034. 0.261 plus 3 times 0.034 will be 0.102. Final answer is 0.363, or 0.261 minus 0.102. The answer will be 0.159. So 3 standard deviation to the right of the mean, the point is 0.363. And to the left, 3 standard deviation to the left, the point is 0.159. What percent of batting averages are above 0.329? This is the portion of the graph that they concern with. The portion that's above 0.329. Now, according to the empirical rule, 95% of the data will fall within 2 standard deviations from the mean. We left with 5%, and since the graph is symmetrical, 5% will be shared equally between the two tails. So 5% is left for both tails of the graph. So for 1/2, which represent the percent that is above 3.329, we have to divide 5% by 2, and we get 2.5%. Therefore, 2.5% are above 0.329. What percent are between 0.227 and 0.295? According to the empirical rule, if we have a bell-shaped curve, 68% of the data will fall between one standard deviation of the mean. As you can see, 0.227 and 0.295 are within one standard deviation from the mean, 0.261. Therefore, 68% of the data will fall between those 2 points.